Welcome to part 2 of velocity time graphs. The next thing we're asked to do within this particular case is we are asked to create a velocity time graph. Now that is again for the data that we had been working with, but now we're going to have an average velocity against time. So this is now going to be on the y-axis. These points here, because they are for intervals, we're going to use the midpoints of each of these as our times. So when we take a look at that, this should be a velocity versus time graph. Velocity we're going to put here in meters per second. Time is still along the bottom. It is in seconds. I'm a little bit cramped there. And we're going to keep the same points, where this one is 0.6. My computer is making this a little bit cramped, but that's okay. So we got the 1.0, and as we put these data points in, call this 0.1, 0.2, 0.3, 0.4, 0.5. This is now the midpoint of that first interval, and it's right there. Midpoint for this interval, and it's right there. Midpoint for this interval, 0.3. Midpoint for this interval, and we're going up to 0.4. And midpoint for the last interval, and it's at 0.5. So as we can see, this is now drawing a straight line. And drawing a straight line through the data should look something like that. Okay, so what are we going to do with all this data? Well, the first one, we said, what does the slope of a velocity versus time graph indicate? Well, if it's the velocity versus time, the slope is the rise over the run, right? And if rise, let me switch back to this, rise over run, where the rise is related to the velocity and the run is related to time, well, velocity over run is acceleration. And so the slope of this line is the acceleration. Now, if we are going to find that, we're going to need to pick 2 points. Let's say like this point here. Oh, my line's gone a little bit off there. I'll erase that. And we need to find another point, something that's on the line. Let's pick here. And so we're going to find the rise over the run. This point here is an x value of approximately maybe about 0.87 at 0.5. This point here, it's a lot cleaner. It's sitting at 0.2 and 0.15. So given those 2 data points, we see that the rise is 0.35. It's going from 0.15 all the way to 0.5. The run going from 0.2 to 0.87 is 0.67. So when you calculate that out, you get a slope of 0.52 approximately meters per second, because that's the change in velocity over time squared. So meters per second squared, 0.52 meters per second squared. And so that is the velocity that we get from the acceleration on the velocity time graph. Next question we got is use a tangent line to find the velocity at 0.5 seconds. So we're going back to this graph and we're taking a look at 0.5 seconds, which is about right here. Right, I'm going to indicate that. I'll indicate that with a little green dot there. And so what we need is a tangent line that will touch that at one spot. Best thing for us to do is to grab a ruler, line it up. So grab a ruler, take the ruler, I need to try to move said ruler. Okay, so I've got my ruler finally set up as a tangent line, and so we are going to run a line right along there. That becomes my tangent line. Now, using said tangent line to find the instantaneous velocity, well, velocity is the slope of displacement over time. And so we need to find the slope of this line. Taking a couple of key points, we'll use this one here. And well, this one here looks nice. We've got a rise going from 0.02 to 0.16, so that's a rise of 0.14, because this is going at 0.6, this is at 0.02. The run goes from 0.3 seconds to 0.65 seconds, so 0.3 seconds and 0.75 means that you're going to have a difference of 0.45. When you calculate that, 0.14 divided by 0.45, you get an instantaneous velocity at 0.31 meters per second, which does fit in line with our data at 0.5 seconds. We should have somewhere in and around that neighborhood. I know that's not exact, but that is what we get. So 0.31 meters per second. How would the instantaneous velocity be different at 0.1 and 0.9 seconds? Well, because this is accelerating at 0.1 seconds, we would expect to see it much lower than we would expect to see it at 0.9 up here. And so we would expect that instantaneous velocity to increase. Okay, how can a negative acceleration mean something is speeding up? One of the things to remember, negative acceleration is really talking about direction, right? So let's say this is accelerating west. Would be an example here, because if something is traveling to the west and speeding up in the west direction, we may give it an acceleration of, let's say, -1 meter per second squared. The negative just indicating west. If something were, let's say, traveling east, its velocity, let's say, is 3 meters per second this way, and its acceleration is to the west. Well, in this case, it would be slowing down because after 1 second, it would be 2 meters per second. And then after another second, it'd be 1 meter per second. And then after a third second, it would finally be at rest. And if it continued to accelerate, it would be traveling that direction. Okay, what we're going to do is get you to copy the Physics Insight on page 28. Just throw it on the side in your notes. Pause the video. Take time to do that. Okay, the next thing we're going to do is we're going to get you to try a couple of questions. The first one being find velocity of the object at 0.2 seconds given the position time graph. Try these three, or try this one. Pause the video, and if you're not understanding, you're not getting the answer, ask your teacher. Okay, so taking a look here, number 8. With number 8, the key thing here is you are taking this line that comes at 0.2 and you should find this time, and this is where you find the slope of this line. Now, in this particular case, given that centimeters per second, that's 167 centimeters per second. Taking a look at the next question, you had to find the slope at 0.3. So that means that we would be taking this graph again, but we're using the 0.3. We're meeting up with this line here. Notice that we've got a steeper line here because it is accelerating greater, and the data you should have got is 277 centimeters per second. What is the acceleration of the object between those two? Well, that's going to be the difference in velocities over the difference in time, change in velocity over time, which gets you 1,030 centimeters per second squared. You could convert that into meters if you wanted to. So for homework, we've got page 30, numbers 1 to 4. Please remember that all your solutions should have first of all, your answer. Second of all, the logic that you use to finding your answer, whether that be with formulas or whether that be with graphical analysis. Whichever way you do that, you're always using proper physics conventions. And your answer should be round to the same number as the questions. Make sure you're only rounding the final answer. Don't round too early. Thank you, and if you have any questions, make sure to ask your teacher.